Hi and welcome to Trig Graphs Day 4. Today we're talking about phase shifts and equation writing with a phase shift. So I know it says recall, we haven't really talked about phase shifts, but the graph of f of x plus c is the graph of f of x moved c units, the absolute value of c units to the right when c is positive, or the absolute value of c units to the left when c is so it was negative, and then we'll see it's positive. This is what we call a horizontal phase shift. So what we're going to do is we're going to take our graph and either move it to the left or move it to the right, depending on whether or not we have a plus or minus inside the parentheses. If it's plus, we move to the left. If it's minus, we move to the right. So complete the graph of y equals sine x, and then the graph of y equals sine of x plus pi over 2. I'm going to graph it between 0 and 4 pi. So graph of sine x is easy. Sine of 0 is 0. The sine of 90 is 1. The sine of 180 is 0. So, 180. The sine of 270 is negative 1. The sine of 2 pi is 0. Just repeat your pattern. So then I'd have 1, 0, negative 1, 0. Now it's really kind of hard to see the graph paper down here. And it all depends on how my screen is tilted, if I can see it. So you may have to adjust the way your screen is going. And I need to do my best to draw a straight line here. Draw my axes in. All right. And that's going to be a half. And this is going to be a 1. That'll be half. And this will be a negative 1. And then every 2 is going to be a point. So pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, and then it would be 6 pi over 2, which is 3 pi, and then 7 pi over 2, and then 8 pi over 2 is 4 pi. And now I'm going to graph my function, my sine curve. So I have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. Repeat my pattern. 1, 0, negative 1, 0. Connect my points. And this is y equals sine x. So now we need to go back up. And now what I'm going to do is add to my x value, which is here. This is my x value. I'm going to add to it pi over 2. So if I take 0 and I add pi over 2, I get pi over 2. I take pi over 2 and I add pi over 2 to it. So if I take 90 and add 90 to it, I'm going to get 180, which is pi. And then I take 180 and add 90 to it, I get 270, which is 3 pi over 2. And I'm going to take 3 pi over 2, which is 270, and add 90 to it again. I'll get 360, which is 2 pi. Hopefully you can see what's happening is all my x values are shifting to the left one space. So this becomes 5 pi over 2, 3 pi, 7 pi over 2, and then 8 pi over 2 is 4 pi, and then 9 pi over 2. All right. Okay, so now the sine of x plus pi over 2. So the sine of 90, because that's, I already figured out what x plus pi over 2 is, so now we're just going to take the sine of all of the values up here. So the sine of 90 is 1. The sine of 180 is 0. The sine of 270 is -1. The sine of 90, or 2 pi, excuse me, 360 is 0. And then I'm going to repeat my pattern. So this should be 1, 0, -1, 0, and 1. So when sine is 0, when x, sorry, excuse me, is 0, I'm doing 0 plus pi over 2, I have 1, so I'm up here. And then when sine is pi over 2, my answer is 0. And when sine is pi, my answer is -1. When sine is 3 pi over 2, my answer is 0. And then at 2 pi, my answer is 1. At 5 pi over 3, my answer is 0. At 3 pi, my answer is -1. At 7 pi over 2, my answer is 0. And at 4 pi, my answer is 1. And then I draw my curve, and this is y equals sine of x plus pi over 2 in the green. Now when you look at that, all I did was I took my original sine curve and shifted it over to the left pi over 2 units. So I basically took each point and went pi over 2 that direction. And you can see that there. So y equals the sine of x plus pi over 2 is just y equals sine x moved pi over 2 units left. Okay, and that is what we call a phase shift. Now, if you look closely at that, that green curve looks surprisingly like a cosine curve. Is a cosine curve and a sine curve are related to each other. The cosine curve is just a shift, a phase shift of the sine curve, cosine and sine. Alright, now you try. Sketch the graph of y equals 3 sine 2 times x plus pi over 6. Well, the very first thing we need to do is find our amplitude, because our amplitude is very important. In this case, a is 3. And then I want to find my phase shift, because that's important. And my phase shift here says plus pi over 6. So my phase shift is actually pi over 6 to the left, because it's going to go in the opposite direction as that sign. Find the period. Period is 2 pi divided by b. B in this case is 2. So it's 2 pi over b, which is 2 pi over 2. So the period is pi. So it should take to pi to finish your, or 180 degrees to finish your curve. And now I need to divide the interval into 4 congruent parts. All right. And then we will sketch the curve. So what this means exactly, let's get some axes drawn here. All right. So because I'm shifting to the left, I need to locate a point pi over 6 units to the left of, if this is a sine function, my sine function starts at 0, 0. So it's to the left of 0. So my starting point would be negative pi over 6, 0, because the height would be 0. So I'm going to let every, let's see here. This is going to be 1, 2, 3, negative 1, negative 2, negative 3. And pi over 6, I'm going to go over here and say this is negative pi over 6 and 0, and that's a point. So I know that my period is pi, so that means it's going to take me 180 degrees to end, till I can end my graph. And that means I need to locate, locate a point pi over 6 units to the left of pi. So what I'm going to do is take pi and subtract from it pi over 6. Okay, this is just a fraction, so this becomes 6 pi over 6 minus pi over 6, which is 5 pi over 6. So my point, my end point, is 5 pi over 6 comma 0, because sine ends and starts at 0. So every 3 I'm going to make a mark. 1, 2, 3, 1, 2, 3, 1, 2, 3. We need 5 points to make our graph, so here's 1. My next one I have to be here, so that's 2, 3, 4, and I need 1 more point. So this is my 5 pi over 6 right here. And I've split it evenly into 4 equal parts, because I'm going to take 12 units and every 3 is a point. And then I'm going to sketch a sine curve would go up to the amplitude here, which is 3. Then it goes back down to 0 at the next point. And then it drops back down to my lower value of the range and then back up. So this is my sine curve shifted to the left pi over 6 units. So my graph is y equals 3 sine 2 times x plus pi over 6. Alright, next part. Now we're going to write the equation for a graph of a sine or cosine graph. Steps for y equals a sine bx plus c. Find the a value, which is the maximum minus the minimum divided by 2. Or we can just look at the graph and look at the high point. Right, in interval notation, the domain of one cycle. So how long does it take to complete one cycle? Write it in interval notation. And I'll show you what that means. And then find the period by using 2 pi divided by b equals x1 minus x0. And then find c, which is your negative x minus 0. That's our shift. So my steps are exactly the same for the cosine curve as well. So for number 3, write an equation of the graph below in the form of y equals a cosine bx. Okay, there's kind of more than one way to do this. I'm looking for a cosine curve. A, I need to look at my maximum point, which is 2. So A is 2. And I think the easiest way to find B, which is the period, how long does it take, is I look at my graph here. This is one high point, this is one high point. Cosine starts at the amplitude. Figure out this distance here. How long does it take to get there? Well, if I subtract pi minus a negative pi over 3, I will have pi plus pi over 3. And I can change this to quickly 3 pi over 3. So I get 4 pi over 3. Okay? And this is the period. Now I need to find B. Usually we have B and then we find the period. Here we have to find the period and then find B. So that means 2 pi divided by B is equal to 4 pi over 3. Cross multiply and I would get 6 pi equals B times 4 pi. Divide by 4 pi to get B alone. So B is actually equal to 3/2. And my phase shift is, how did I shift it? Well, my starting point is usually right on the y-axis. And since I move to the left, my C value is going to be positive. So C is going to be a positive, and this is negative pi over 3, so it's going to be positive pi over 3. So to write my equation, it is y equals A is 2 cosine of B, which is 3/2 x, and then 3/2, and then x plus pi over 3. And that's a 3. Sometimes the 3's are hard to see. So that's my cosine curve. Alright, and to finish it up here, 4, write an equation of the graph from example 3 as a sine function. Well, I'm going to do the same thing. My amplitude is not going to change. If I look, just looking at the graph, my highest point is 2. So A is 2. Now, sine curves go from 0 to 0. Okay, so this is my sine curve here, between here and here. So to find my period, I'm going to do 2 pi over 3 and subtract from it a negative 2 pi over 3, because that's where it ends. and I will get 4 pi over 3. Amazingly, the period is the same for these two graphs, and as it should be because it's the same graph. So this is the period. So then to find b, we're going to take 2 pi divided by b when set it equal to 4/3, or 4 pi over 3. When you cross multiply, you should still get b to be 3/2, because the math doesn't change from the part above. Now I have my b value, my a value. I need to find my c value. I move this to the left, 2 pi over 3, so my c is going to be a positive 2 pi over 3 because I moved it to the left. So my actual equation is going to be y equals 2 sine 3/2 and then x plus 2 pi over 3. So really the only thing that changed between these two equations is just the fact that one is x plus pi over 3 and this one's x plus 2 pi over 3. And one is cosine and one is sine. Alright, that's it for equation writing and phase shifts.